So I am now the proud owner of an AS number, 201726 specifically. So if you're like most of the people in my life who aren't on my Discord server, you're probably like, what the hell is an AS number? Do I need one too? Almost certainly you do not need one too, but this should lead the way to some really fun internet scale experiments on my channel in the future. So real quick, what is an AS number anyway? Well, in short, it identifies very large networks across the internet. So in the early days of the internet, we were in internetwork, a collection of multiple networks which were internetworked together around the world. And originally, we used the first digit of the IP version 4 address for this. So if you look at an IP address like 8.8.8.8, Google's DNS, originally, everything starting with an 8 was owned by a company called Bolt, Burnett, and Newman. They were actually the developers of the ARPANET router, and they were heavily involved. 9.9.9.9, that's another popular DNS resolver. Everything starting with a 9 was owned by IBM. I'm sure you know they were really into computers. And actually 10, the reserve network now, that meant the ARPANET. So the ARPANET was a network, and at the internetworking level, it was just one of the many networks available. So fast forward now to today, and here is an example of a server on the internet. You can probably guess who it is. The address is 2606.4700.0.0.0.6810.85E5. So what does that all mean? Well, this is a global address, so anyone on the internet can access it. The last half of the address, 00.6810, etc., that identifies the host uniquely. So we can tell that is a specific machine within a broader network. Most of you guys do subnetting at home. If you follow my channel, you probably have at least a couple subnets. If you follow some other security people's channels, maybe you have more than a dozen subnets at home. That is a subnetwork, a network within a network. In this case, there's none, so it's just a 0, but maybe you're doing your own subnetting. If you're an internet service provider or a customer of an internet service provider, all of your networks are probably subnetworks of their network. You probably aren't your own network, so to speak. So an internet service provider could have millions of subnetworks under their network. So in this case, the network is 2606.4700. Then we have a 0 for the customer subnetwork, a 0 for the subnet, etc. But if we go up a level again, this particular company owns, half a dozen of these networks. So they own 2606.4700. They also own 2 A06.98C0 and 5 more. So how do we identify this specific organization on the internet? We do that by their AS number. So in case you haven't guessed yet, my example address here is Cloudflare, one of the largest CDNs in the world, and their AS number is 13335. That's a lot of threes. Their ASN is also a bit smaller than mine. Mine requires 32 bits to hold it, which causes problems for some people, but 201.726 is mine now. So, because I have my own AS number now, I can go straight to the top, the internetworking layer, and internetwork with other networks with my own network. So I can peer with people like the content delivery networks of the world, the ISPs, the regional ISPs, home ISPs, etc. If I had enough clout, I guess I could do that. I'm peering with one company now called Vulture, who hosts virtual private servers. And for me, the advantage of having an AS number is that I have a lot more IPv6 address space to play with. I've been doing labs over the past year or so where I'm simulating an internet service provider, and you guys have complained rightfully that I'm not giving my customers enough address space. It's because I'm trying to fit in the amount of address space I have as I'm already a customer. So I'm doing like a subnet of a subnet of a subnet of a subnet, and it's just too small to work with. Now I have enough address space that like a small startup ISP might have, so I don't have that problem. Also, I have the ability to do my own traffic engineering. If you're relying on a bigger player like your internet service provider, you're sort of at the mercy of how they peer with other networks, and you could switch ISPs or something like that. But since I have my own AS number now and my own address space, I can peer around the world. I'm not tied to one upstream, and I can do my own traffic engineering with BGP communities and things like that. So that's for the why, but how about the how? So there are really maybe 3 other organizations involved in me getting this set up. The first is Zenith Cloud out of Toronto. They're an IT consulting company. They run cloud services in Toronto and networking services around Canada in general. So they helped me get the AS number and they've let me use a /40 of their address space. So I do not own my own provider independent address space. I'm using their address space, but I can still route it and BGP advertise it freely on my own. The second company involved is Vultr. They're the company I'm using to host. So I am paying them to host servers in their cloud. My servers in their cloud are then peering with them, and that's how I establish my BGP presence for a reasonable price. And the third organization involved is RIPE NCC. So I live in Finland. That's within the territory of RIPE. That's some sort of French acronym. They manage all of the internet addressing in the European region. So I got my AS number from RIPE. I manage things in the RIPE database, my organization, things like that. So that's RIPE. RIPE also has some really good tools and documents on high-level internet network routing in general. I'd say they're one of the best RIRs from that perspective. Oh, by the way, if you're interested in Zenith Cloud, I have a link down in the description below. It is an affiliate link with my ID number tied to it, so thanks for that. I got in contact with these guys because they're actually fans of mine and they're members of my Discord, so that's how we got in contact. They've given me a very reasonable rate for their services, the /40 and the AS number management, and I'm very happy with that. So then the next step for me was, how am I going to get transit? So I already mentioned that I went down the path of choosing Vultr for this, but there are other options. So there are some companies that offer transit over tunnels. So my network, I'm obviously not directly physically wired into an IXP or even to a service provider I can peer with directly. So I'm here at my home with Elisa. I have a /56 IPv6, but they're not going to do BGP with me. So I'm establishing tunnels out to cloud servers. The cloud servers are then BGP peering with the internet. So that adds quite a bit of extra latency to this whole setup, and that's why it's mostly just for experimentation. But if I was actually running my workloads in the cloud, I could just run my workloads there and it'd be nice and fast. So there are companies around that offer tunnel broker services with BGP peering. I wasn't super happy with the pricing on those compared to Vultr. Hurricane Electric used to offer this for free for IPv6 as part of their broader tunnel broker service, but they've been reducing their tunnel broker offerings or more restricting them to well-known customers for a while now because of abuse. So my next choice was, where am I going to locate? So here are all of Vultr's locations in the Western world. So I am located in Finland. So Stockholm would be a reasonable choice. We also have Warsaw, Poland. We have Germany, Amsterdam, Paris, 2 in the UK, etc. So at this point then, I took a list of every server data center Vultr has. And they have a page where you can do a speed test to their servers, but just by downloading a big file. And so all of these servers respond to pings, obviously, so we can trace route them. So I took the list of every server Vultr had over IPv6 and IPv4 separately, and I did a trace path to them. So I was looking at where the path is going from my home internet here in Elisa, because the path you take through the internet is really not the path you would think you'd take over the ground. So, like, as the crow flies, the distance from me to Stockholm is much shorter than me to Warsaw. However, the route from me here in Finland to Stockholm, Sweden, my ISP has decided to peer in London. So going from Elisa to whoever the operator is that transits to Stockholm, I think it's Aurelion 1299. Elisa is peering with Aurelion in London. So all my packets go to London and back to Stockholm, which is not great. So I actually found that the shortest ping time from me here in Finland was to Warsaw, Poland. Stockholm was actually not that much worse. My packets to Poland actually go through Germany first, which is kind of weird. But I picked Warsaw because I'm also operating a Proxmox backup server at Scaleway, and they have a big data center in Poland as well in Warsaw. So my Vultr server is only about 1.5 milliseconds away from my Scaleway server. They're probably in the same building or next to each other or something. So that's why I picked Warsaw over Germany. Now I wanted to have one other point of presence so that I could do Anycast testing. And for that I wanted something that was in North America and had good transit to the rest of the world. So for that I chose LAX, Los Angeles, California. LAX will have better peerings across the Pacific, so than like Chicago or Ashburn, Virginia. So sorry to people on the east coast of the US, you got a little bit worse of a deal, but hopefully the people in Australia aren't doing too bad. I think my ping time to Australia is still like 250 milliseconds, so kind of sucks to be down there, right? So with that established, here are the locations on my 3 routers. So I have LAX, I have Warsaw, and I have my home location in Finland. And I then established 3 sets of tunnels between each of these 3 sites. So my initial network is just what we call a full mesh. Every site's directly connected to every other site. I'm using IP for this, so I'm not using any UDP, WireGuard, IPsec, not even GRE. It's just strictly IP inside of IP. Well, v6 actually for both sides. So IPv6 in IPv6. I'm running these tunnels just with basic Linux commands. So next up, I gave each site a number. So 1 is in Warsaw, 2 is in LAX, and 3 is at home in Finland. So I use this number in quite a few places. I can use it in BGP communities. I can use it in IP addresses on the tunnels, loopbacks on the routers, the IPv4 style router ID, things like that. Also, I'm sure I'm going to get some hate for not using WireGuard across these links, but essentially these are WAN links. They're running over the internet, and the traffic flowing over them should be treated as if it's running over the internet and not over my private network or private LAN. So I should be encrypting traffic end-to-end through web server, things like that, and not relying on transit encryption by my ISP, which is essentially I'm acting as my ISP here. So that's why I chose IP with no encryption. I still probably should do some encryption on my OSPF and BGP sessions, but we'll get to that. So next up, I decided that my very first /64 out of my /40 allocation is going to be my loopback addresses. So each router just has its number here. So for example, one of my routers is 2AOF B240100001. That's the router. And then 2, 3, you can ping them if you want, please don't. But so the /128 router addresses go into OSPF. OSPF establishes adjacencies across these tunnels. Now these tunnels don't support multicast, which OSPF normally uses. So I've set up link local IP addresses, which again are just FE80 : router ID. So FE81 would be all the addresses on router 1. FE83 would be all the addresses on router 3, etc. And I forced Bird to use Unicast with listed peers instead of multicast across these links. So once all the loopbacks are up, everyone in the network can use that as their next hop. I was actually recommended to also include all of my next hops, one hop outside the network as well. So in this case, my 2 Vulture gateways I should include as well in OSPF, so I don't have to change next hop to self on BGP. But I'm using next hop self on BGP, so we'll get to that as well. So at this point, I have adjacency set up in OSPF. I can ping the 3 routers from each other across any of the links. I can take any of the tunnels down and it'll reroute. That's all working pretty well. So my next step at this point was to establish BGP across the tunnel. So in a service provider network like this, normally you would have a route reflector somewhere that manages all of your routes. I have only 3 nodes, so I'm doing a full mesh. So with iBGP, internal BGP, we can't do multiple hops. The route can't propagate through multiple internal routers to prevent loops. So my 3 routers all have to talk directly to each other. And if they lose that BGP adjacency, they lose those routes as well. So, which makes sense with only 3 networks. If I had more routers, I would use a server somewhere or a pool of servers that would share all the routes with everyone involved. I'm using Bird as my daemon, by the way, of choice. So here's what my Bird conf looks like. It's not all that complicated. I'm just sort of learning how to set up different filters, learning how to handle stuff like this. So what do I put in the kernel? I put in my own routes from OSPF. I put in my own routes from my prefix. I put in NAT64 routes, etc. Here's what I mean by OSPF. I have it's set up to use neighbors on tunnel networks. I'm learning how to do BGP communities. I'm not that good at it yet, but we're getting there. So once I had my 3 routers sharing routes with each other correctly, making sure I'm not going to take in, send out the wrong things, I established my first peering with Vulture. So then I took in a full IPv6 table, which is only about 150,000 routes. It's not that big. And also the reason I chose Bird in the first place is because it's way more memory efficient than FRR. FRR was using like 2.1 gigabytes in my testing to do full table v4 and v6, and Bird was using like 500 megs. So like something is seriously wrong with how FRR handles, well, a lot of things, but code quality is not a high point of FRR. So by using Bird, I'm able to use a 1 gig VM instead of a 4 gig VM, that saves me a lot of money every month. So as soon as I had these peerings set up with Vulture, my first step was to announce something to the world. So I chose to advertise my first /48 as Anycast. That means it's coming out of both of my peerings in Warsaw and in LAX. And in theory, if you ping one of these addresses, I've set up 420 as an address on both nodes, so both nodes will respond to pings. So if you ping my Anycast 420, it should respond from the closest node. Anycast should just magically work. And I tried that, and here's what I got. So I went to RIPE Atlas, and I did a trace route measurement to my Anycast address. And I would expect everywhere in Europe to be pretty green, and I would expect everywhere in the US to be mostly green. And I kind of expect South America, Africa, etc. to be red, because I don't have any hosts there. But if I zoom in here, what the fuck is this? So my server is in Warsaw, so I would expect all these guys to be green. They're not that far from Warsaw. But like Berlin here is not far from Warsaw. And what does this path look like? So it's going from some customer of Telefonica, who is AS6805. So it's taking them through NTT, Nippon Telegraph and Telephone, to, so AS20473 is Vulture, to me. And if you look here, this server is LAX. So it looks like these guys are peered with someone who's peered with NTT, and NTT's carried it all the way across the world to LAX. And how about this one as well? So Austria, again, we're going through NTT to LAX. And like what is wrong here? Is this one going over NTT? This one's going over level 3. So whoever this is, AS3262 in Spain, they're peered with 3356, which is level 3, and they're only peered with Vulture in LAX. So essentially what's happening is there are a number of tier 1 providers around the world, and Vulture isn't peered with every one of them at every one of their data centers, which makes sense. So if I get an ISP that is directly peered with NTT or with level 3 or something like that, they are peered very closely to me in LAX. So BGP doesn't look at the number of routers we take, the number of milliseconds we take. It looks like the number of ASs we take. So to get from a customer in Spain who's directly peered with level 3, it says I have to go through my local AS, I have to go through level 3, I have to go through Vulture, and I have to get Appelard. It's 5 ASs. That's about as good as it gets. So maybe if I was going through, say, 1299 Aurelian, maybe I would have had to take one extra AS hop, even though the actual path, number of routers, number of milliseconds, etc., by any other metric is shorter. So is the same thing happening over in this side of the Atlantic? I don't know. So LAX obviously has very short peering time, and that's from AS7018, which is AT&T. How about these guys here in Detroit? So we might actually be doing the opposite here in Detroit. So AS399805, I don't know who that is, but they're jumping onto AS174 Cogent, and that is taking them through, it's like none of these guys are responding. But with a time like that, it could be crossing over the Atlantic. And how about like Colombia? What does that get us? It's like that's taking us to LAX, and it's just because it's far away. So I asked my new friend about how do I resolve this, and he basically said, well, you got to learn BGP communities. So BGP is the political protocol of the internet. When we exchange routes with each other, we exchange a lot of metadata, and it's something that none of the other routing protocols really have. So like OSPF, ISIS, they're widely used IGP protocols, but they don't carry route metadata like BGP does. And so in BGP, a lot of this metadata is carried in the form of a community. So a community is essentially like a number that gets added to the route. And it always starts with the AS number who originated the community, or who takes meaning in the community, I guess I should say. So I can create my own communities that start with 201.726, and they mean anything to me. And if I share my routes around on the internet, and I tag routes as they come in, or as they go out with 201.726, that has meaning for me. But every provider has some meaning in what their community numbers mean. So Vulture has a list of what their community numbers mean. Let's take a look at that. So here's what Vulture's communities look like. So they're AS204.7.3. So their communities, most of the ones I used were their large communities. So they add communities to their routes that say what AS it came in on. So 204.7.3.100, and then the AS number it came in on. If it came from a route server, it came from a bilateral peering, etc. So I can look at my routes that I get from them and see where they got that route from based on the communities they've added. But I can also add my own communities to my routes down here, the action communities. So if I add a community that says 204.7.3, 6000, 1299, it means do not advertise this to 1299. And so I can say prepend, I can say set metric, etc., and use this to steer my traffic as it leaves Vultre's network. So prepending, by the way, is a way of making the AS path longer. So in BGP, the route metric we use most of the time is the AS path length. So like I said, if you're going from one AS to another AS to another AS, we assume that ASs are pretty good at routing within themselves, I guess, which is why some of this international stuff breaks down a little bit. But basically, prepending our AS adds our own AS number more than once. So it makes the path artificially longer. And so by telling Vultre to prepend this, but only to specific ASs, we're saying pretend like we have one extra network in between us and them, and make that path a little bit longer so that we'll only take it if we're really quite sure that that's a good path. And we can do that up to 3 times. So I went through and I looked at what providers were causing me traffic problems, and I came up with a short list, and I did a little bit of prepending to fix that. So here's what it looks like on my bird config. So I'm prepending once, so 6001 needs 1 prepend. 2174 with this Cogent. Cogent wasn't that bad, so they only got hit with 1. Level 3 and NTT are both causing me tons of problems, so I added prepending of 2 to them. And then AT&T somehow directly peered with Vultre in the eastern US. So they were getting a direct connection to Warsaw out of basically the entire US, which is very wrong. So they get prepended 3 times, so they have to go through someone else and not their direct connection. So I also have the ability, if I know who's peering with who, I can change these on each of my egress routers. So that, for example, if I know that Cogent is causing me problems in LAX, I could prepend out of LAX, but not out of Warsaw, for example. In my case, it seemed like most of these ISPs that were causing problems were only peering in LAX, and that everyone out of Warsaw was pretty much universally using Aurelion 1299, and they handled my traffic just fine. So, yay for Aurelion, I guess. And actually, my sort of BGP mentor here recommended starting with turning off everyone. So there's a community you can use to say, don't advertise this at all. And then another community you can say that says, turn it back on, but just for 1 AS. So he said, turn off everyone but 1299 and one other, and then work up from there, instead of just sending to everyone the same data. And so this is what I ended up with, and let's take a look at what the RIPE Atlas reports now. Okay, so that's helped. So obviously we still have some very long distance routes across far parts of the world. Got someone here though that's still doing something bad. It's around in at 7. That's the ISP that advertises like 50 gig or something. And it looks like in at 7, 13030, is peered directly with NTT, who is not peered with Vultre. So they're still getting the NTT route. So they must have quite a few more hops to get to Warsaw. Or NTT is ignoring my prepending, which could also be happening. But we're doing better. So we've fixed up this a little bit. So maybe I should just not advertise to NTT out of LAX. That's one option. So these guys are taking Aurelion, and it looks like Aurelion is peered with Vultre. So I'll, of course, keep refining my communities I'm sending out to Vultre. Maybe NTT's ignoring my prepending, I don't know. I could just not peer with NTT. There's a community I can do to tell it that. I could try prepending 3 times, see if that works, I don't know. RIPE Atlas also has this really cool tool here. Take a look at this. They call it Khipu. How do you pronounce that? Khipu. And it looks like this. I wish I could zoom in better for you guys, but so at the center is me. And then here are all the different next hops that get there. So it looks like there's only 1, 2, 3, 4. So this next hop is seen by a lot of people, and it's in the US. And this next hop is also seen by a lot of people. I guess it's not in the US. It's so these are all the different paths probes took to get here. And so I'm guessing one of these is in Warsaw, one of these is in LAX. So let's pick this path here. Bring it over. So this is from France, 12322. They're hitting up 1299, and they're going to Poland. So they're taking the Warsaw path. So this router here is probably Poland, and then this one here would probably be the US. So we go off on this side, and we pick this trace. And so it looks like this is from, it says it's from the Netherlands, but that's where it's registered. And they're again hitting up 1299. BR0MK, that looks like a US. And so they're ending up in LAX. And again, where does it show? It shows the latency here, 40 milliseconds. Yeah, there's no way they're actually from the Netherlands going to LAX. So then if I sort this by RTT, we get some weird outliers here that go way off into the ether. So this guy here is from South Africa, and I'm not sure what path he's taking. I think he's going through LAX. I don't think I can do any better for South Africa. I'm sorry, South Africa. So when I started playing with this, I was seeing outliers like this that were clearly in a region that I should have good coverage, that had very long round trip times. So like Ecuador, I'm expecting these places to have long times. UK, okay, so these guys in the UK, they're going through NTT, NTT's still fucking them up. So this is a really cool tool. It's a really great job to, I guess, RIPE, for running RIPE Atlas. I'm actually going to start running my own RIPE Atlas node now. I've been a RIPE member for a long time. Not that I did anything with that account, but I had an account. So I'm going to start running a RIPE Atlas probe now. Running a probe on your own network, even just like a simple VM or container in Proxmox, gets you credits to use the service. You get a certain number free every month. So if I run my own probe, I can do a lot more measurements like this, which is super cool. So yeah, I guess I got a little bit more work to do with Anycast, but making progress, right? So now where do I go from here, I guess? So I don't think I mentioned, but I have IPv4 at each of the Vultr sites and at home as well. So that's just a single address. So the VPS has a /64 out of Vultr's prefix and a single /32 IPv4. And so I can use that as well if I want to, in addition to my prefix space. And so I'm using that for the underlay, obviously, the OSPF neighborships. Those are running, the tunnels are running from those addresses. I'm using the v4 addresses, obviously for v4 BGP peering, but I can also use that for NAT64. So my whole network is IPv6 only, but I can still carry v4 egress traffic with NAT64. I developed Taiga, of course, probably a video up here on me taking over Taiga. So I run Taiga on all these nodes, and I can choose which one I want to egress from by using a different prefix. So like 64FF9B:1:1 takes me out of router 1, :1:2 takes me out of router 2, etc. So I can set that up at the network level where I want it to go, which I think is super cool. So the next thing, I guess, for me is to start migrating some of my services that I already run at different clouds around the world into this infrastructure. So I think I already mentioned I have a Proxmox backup server running in Scaleway. That's going to stay in Scaleway because I save a ton of money on bandwidth. So their S3 service at Scaleway is very cheap. Bandwidth, especially egress bandwidth, is not. However, if you run a VPS, traffic within the same region is free. So I run their cheapest VPS, which is like less than $1 a month. It's amazingly cheap. Heavily oversubscribed, but I don't care about that. This is Proxmox backup server, limited 100 megabit. Again, don't care about that. And so I'm running that in Warsaw. And then I also have 2 servers at Hetzner. I have one in Ashburn, Virginia, and one in Helsinki. And so I'm probably going to migrate those services over to run on my new Vultr VPSs, maybe upgrade them to 2 gig a month, or 2 gig RAM instead of 1 gig. We'll see about that. But so that would be hosting my website, hosting services like that, and then sort of fronting a lot of the services I self-host. So I can't really receive incoming connections very well because of the poor firewall config I have here. So here at home, I really need to work on replacing my router and my cable modem. And I have that coming up in a project eventually. So as I do that, I can receive incoming traffic here as well for my self-hosted services for me, which you guys don't see. Like I have a task planner and things like that that I self-host over the internet, Home Assistant, Imish, things like that. But I could front that through my sort of CDN as well, so that wherever I am in the world, it'll connect to my nearest POP and then route it back home or wherever the server is actually located. So maybe I'll start playing with that. If I was wanting to try some sort of geo distributions, maybe I'll start like a PeerTube just to experiment with it, not like to actually migrate to PeerTube. But so things like that. That's where I'm going to go next. I'm enjoying playing with Anycast. I also have a /40 to work with, and I'm only using a /48 right now, the Anycast range. So my plan also is to use that /40 for my mock ISP. So I think you've seen videos in the past, like my fiber video, where I set up like a whole ISP setup over fiber optics. I'd like to get more into the core network side of that, so setting up a BNG for that, how to do PPPoE versus IPoE, the different types of IPv6 transition mechanisms we have, so 464XLAT, MAP-T, MAP-E, DS Lite, things like that. And so having this address space that's bigger than what I have at home will let me experiment with things like that. So like with MapT, for example, they code in your subscriber ID into your IPv6 prefix. So if I give each customer a /56, that means if I'm going to split up a single IPv4 address 16 times, I need at least 16 times /56s just of address space just to make MapT work. And so I can't really do that with what I have at home, even if I give them really small prefixes. So having this address space will help me do more experiments like that without using like the documentation space. So now everything will actually work. I don't have to do NAT66 just to make my test setups work. And so that's where I'm going from here. I am going to start doing some automation eventually of this, but currently I'm just logging into my routers in Visual Studio Code and editing their config files. So we'll get to that as well. This is definitely just the first episode of my series on starting my own AS. I hope you guys enjoyed this. If you want to chat more about networking, service provider networking, stuff like that, Discord server link down below for that. If you want to chat with me personally, Discord or Mastodon is an option. If you like my shirts, this is actually not a shirt that I made, but this is one of my favorites from the Connections Museum in Seattle. If you like my shirts, I have shirts down below as well, including the famous HomeLab Personal Data Center with a graphic of a PDP-8. So if that's into you, check out my Ko-fi, and I guess I'll see you guys on the next adventure.